Welcome to the Innovate Europe podcast, where we talk to the founders and funders and all those who shape the European innovation ecosystem. I'm your host, Clark Parsons, Managing Director of the Innovate Europe Foundation and the CEO of the European Startup Network. And today it's really an honor. I'm joined today by Hermann Hauser, venture partner and co-founder of Amadeus Capital and the founder of ARM. Hermann, you also, everyone knows in Europe, you have a degree in physics and are synonymous with Silicon Fin and the rise of Cambridge as a tech ecosystem. Way back when you co-founded Acorn with Chris Curry in 1978, which developed the BBC Micro and the ARM processor. Later successfully spun out ARM Limited. I can't wait to talk about all these topics. Later, you became the vice president for research at Olivetti when they took over Acorn, and you founded the Olivetti Research Lab. And you've, of course, as many know, founded several other companies, including the Active Book Company and Amadeus Capital Partners, a really well-known venture capital fund in Europe. Co-founded that with Ann Glover and Peter Wynn, and you're a venture partner there. So for many people, you're the man who needs no introduction. I didn't even mention your stint on the board of the European Innovation Council. It's an honor to have you with us. So thank you for joining us today, Hermann.
Well, it's a pleasure to be here. Thank you, Clark.
You are, for me, one of the great Europeans in the sense that you were born someplace where you've not made your career, which is, I think, something that many Europeans now in this generation do as a founder. Take us from the beginnings. I think you're from Tyrol in Austria. Take us from how a young student and interested in science person ends up in Cambridge in the UK, studying and making your life there. How did you get there?
Well, it was actually quite a convoluted path in the end. And although, as you rightly said, I grew up in the Tyrol, I was actually born in Vienna because my mother was Viennese, and my father always sent her back to Vienna when one of her children was born. But I spent most of my childhood and my early days at school in the Tyrol, and had a wonderful uncle who was a physicist and a mathematician. But there were no jobs for physicists and mathematicians in those days. So he actually became the local jeweler. But he was still so excited about physics and mathematics and kept telling me about it on our many walks through the mountains. So he really instilled this excitement about physics and the sciences in me. So I never really wanted to do anything else but do physics.
Well, wanting to do physics and ending up at Cambridge are, of course, two different things. How did you end up at one of the great places for physics in the world?
Well, I suppose the first thing to tell you is how my father, who was in the wine business, he had a wine business in the Tyrol, how he allowed me to study physics. So I'm the first person with an academic degree in our family. So my father was not an academic. And so he thought he would do some research on whether this is a sensible thing to do. And he called an expert witness who was a friend of the family, who was an assistant professor in physics at Vienna University, as the sort of person to advise the family whether Hermann ought to be allowed to study physics or not. And he analyzed it as academics do, very in great detail. And he came to the conclusion, because of my school results, that I would probably be able to finish the physics degree successfully. And he was also telling me that this is a very satisfying job to have as a professor in physics. But he then advised me that I would never have any money in my life. So and my father then turned to me and said, "Well, is that really what you want to do?" And I said, "Yes, father." And he let me. So I'm very grateful. So I studied physics first at Vienna University for my first degree, and then I did my PhD in the Cavendish because actually, again, my father sent me to Cambridge to learn English when I was 15. So I had a great affinity with Cambridge for many years before I started the PhD there.
That's brilliant. And I mean, back then, it wasn't like going into the priesthood, taking a vow of poverty, but the world of personal computers and tech was still in its baby shoes, as they'd say. So I could imagine somebody would say, like, maybe there's no future in this, physics or electronics. What was it like in those early days because, I know in the 70s, at least in Silicon Valley, there was this spirit, we know from Steve Jobs and Steve Wozniak, this sort of spirit of basteln und tüfteln, as our German friends would say, like of sort of the garage of figuring things out, building tech. How did you end up going from physics into technology there?
Well, it was an absolutely wonderful time, the late 70s. It's not unlike the excitement that young people have about AI at the moment. But in those days, it was about the chip. So they called the microprocessor the chip. And the BBC produced a very now very famous program called "When the Chips Are Down," and what they meant when microprocessors will become part of our lives. And they predicted that every one of us will have one in our households. Little did they know that it will be hundreds, probably thousands now in most households. And there was a microprocessor group at the university, which we all joined, to enjoy that vision and that excitement about how the chip will change our lives, how it will be, enabling all kinds of things that we dreamt of, which of course have become reality. And we just wanted to be part of it. And just as you say, the first wave was actually home computers. So everybody at the microprocessor group actually produced their own little microprocessor kits. And the first product that we had at Acorn Computers was a microprocessor kit that for I think £79, with a hexadecimal keyboard, and you could program it. It was 6502. You could program it in assembler. And we produced a very powerful, very complete microprocessor, which perfectly fitted the market, because the people that produced that microprocessor kit, which we then called the System 1, were actually the people that wanted to use it. So it was the perfect combination between market research and clever people doing it, because the people who were doing it were actually the market. So they produced the perfect specification of the machine. Now, one of the interesting specifications, which was essential, of course, was that when you put the kit together, it mustn't work. It was very important that it must work first time, because the satisfaction was to make it work. So you had to fiddle around with it and finally make it work, and that was really something that we did very well. We produced things that didn't work.
What was the insight that led to the founding of ARM, which is, of course, the company that most people associate you with? I mean, these breakthroughs in getting the chips smaller and smaller and more efficient. I mean, what was for you a key insight that led to the building of this chip empire?
Well, it was really, ARM is an outlier in so many dimensions. But the first dimension is that the idea for a RISC machine, a reduced instruction set computer, is actually an idea that John Hennessy at Stanford and Patterson at Berkeley came up with. So as opposed to Europeans inventing it and Americans exploiting it, this is one of the few examples where the Americans invented it, but we actually exploited it first and most successfully with the ARM. So at the time, we were using the 6502 8-bit microprocessor, the same microprocessor as the Apple II, that the BBC Micro was based on. And we were running out of performance. We looked at every 16-bit and 32-bit computer in the world at the time. We quite liked the 16032 from National Semiconductor. That was actually one in the final choice, and the 8286 from Intel. So we went to Intel and said, we quite like your 8286 for our next computer, but you screwed up the pinout. Nobody can make a sensible computer with that stupid pinout that you have. But if you change the pinout for us, maybe we can make something of your chip. And of course they said, who the hell are you? Get lost. Now, I was the Steve Jobs of the UK at the time. I felt I was an important person on a global scale. Of course, I was not. What, get lost? You get lost. We'll do our own. And that was the only reason the ARM exists. Now, this with some satisfaction that the value of the ARM has now overtaken the Intel market cap. So we have succeeded in our ambition to beat Intel.
That's brilliant. It's also, I guess, maybe, as you noted with the AI race, once again a signal that perhaps the second mover can also still leapfrog. So there's a lesson I think there to be learned. Also, when you look at the fever going on in AI, what kind of parallels do you draw? I mean, do you see that make you optimistic about where Europe is right now technologically?
Well, we do, as opposed to previous problems that we had, say, with Google and Facebook, where it all went to an American monopoly. We do have Mistral and Aleph Alpha in Europe that produce very nice large language models. And of course, it is far from clear where the real value accrues. So if the real value accrues in the rollout of AI, then Europe has as much a chance of taking advantage of AI as the US. But it must be said that the US is rolling it out faster than Europe does, partially because of the cautious nature of Europe adopting new technologies.
But also, is it to some degree a capital question? I know you've been really working hard to get more capital into the system. And of course, you've been an investor all these years. I often feel like the fact that it's so hard to scale quickly in Europe is often because it's so hard to fundraise quickly in Europe, or fundraise with the size of checks that the investors can deploy. What role does getting more capital into the system play? Because I know you've also been instrumental in having the UK government help commit more pension fund investment into the ecosystem. So I know this is something that's close to your heart, you've been working on for some time.
Yes, it is. And I perceive it as probably the single biggest gap in the fabric of financing Europe, because Europe's universities have an output that is comparable to American universities. We actually produce more startups in Europe than in the US. This is a little known fact. So the big problem that we have is scale-ups. And of course, the initiative that we've just started at the EIC, the European Innovation Council, to raise 20 billion for growth capital in Europe is trying to address this gap.
Super. I mean, one of the things that's also fascinating for me, I've been in Europe almost 30 years. For a long time, there was this talk of where is Europe's Silicon Valley? And I think we've now come to realize that one of the great strengths of Europe is the fact that there are so many clusters, each with centers of excellence. So, maybe it's not a bug, it's a feature that we have, not only Cambridge, but then you look at Munich, you look at Paris, you look at Stockholm. I mean, we can really rattle off these different areas, often built around maybe a research institution and access to talent and capital. How do you see the good ingredients for building these kind of tech ecosystems? Because you've been a part of making it happen in Cambridge, but Europe is starting to really speed up and recognize the need to feed these kind of ecosystems where they are, and not try and just get one.
Yes, I think that's right. And at the center of all these ecosystems, you'll always find a world-class university or a world-class research institute. Actually, it's normally universities like Oxford or Cambridge, or Imperial and UCL in London, TU, the Technische Universität in Munich and Berlin, Barcelona, Stockholm, Helsinki. Just you rattled them all off. But it takes a while for these ecosystems to congeal and become really productive because you need the entrepreneurial spirit. You need a few success stories that then breed further success. You need to have a local venture capital community that supports these companies. And you need lawyers and accountants that understand the rather peculiar accounts of startup companies that might have big valuations and a lot of money, but no revenue. This is something that happened to us at Acorn, where we were with the first company in the UK to go from 0 to 100 million revenue in 5 years. And when the accountants came to do the accounts and we asked them to comment on the accounts, they always came out ashen-faced saying, "We've never seen anybody overtrade so badly in our lives. Stop what you're doing." And we said, well, this is what the last one said, just go away. We continued with our meteoric rise in those days.
Overtrade, that's a phrase I've never heard before. They thought
Oh
you were doing
yes,
too
that
much
was a
business.
very well-known accounting term when your revenue was well above the capital that you had in the company, and that was deemed to be a bad thing.
Boy, we should all hope to be overtrading then. That's fantastic. I mean, it is funny also. You really also created this path that I think is more common in Europe than in the US, which is of the researcher or scientist specialist going into the business world, because usually Europe is not known for having a bunch of MBAs or business school people founding companies. It tends to be, especially because so much deep tech is research focused, a lot of our founders are people like yourself who started actually in science. What kind of advice do you find yourself giving the most to these kind of founders? Maybe some of the things you learned along the way about how to make this transition from science into business.
Yes, well, we've done a lot of research on that, and the result is that if you're building the initial team, it actually does help to have an MBA student or somebody who has a bit of business experience. In my case, my partner Chris Curry had a lot of experience from his time with Sinclair, which was a company that was in electronics and knew how to sell electronics products. So both had knowledge of where to buy the components, get the chips, and also how to sell these early stage home computers through advertising in the magazines. I mean, these magazines were very popular. There were racks of these magazines in the local newsstands, and people would be very excited to buy things like Personal Computer World and things like that.
That's great. Yeah, I mean, I still remember those days, and in fact, a lot of tech founders from my generation will, of course, go back and say, "Dad bought me a Commodore 64" or something. So tinkering with the tech was definitely the way in for a lot of people, even the business people. You mentioned also, the universities being an essential piece of the puzzle in Europe. One of the things that I think many of us would like to see happen quicker or better is this notion of spin-offs out of the universities. It's something that the ones that have cracked the code, you mentioned Oxford and Cambridge, and I think also of Unternehmertum or the Technical University of Munich, they've found a way to create an ecosystem that's spinning a lot out from the research world. What do you think we need to do to replicate that across Europe and get more of it, and even make Cambridge and Oxford better at it? Is that something where we should really put some focus?
Yes, of course, it's improved enormously. When I first started doing this in Cambridge and other British universities, I remember the reaction I got from professors when I suggested they ought to do a spin out from with the breakthrough that they've just had. The reaction is, "Who do you think I am? Sullying my pure academic hands by doing this deal with Mammon? Go away." And this has all but disappeared. And the argument that finally won the day, and I remember working on this report with the then science minister in the UK, David Sainsbury, and the report was the race to the top rather than the race to the bottom, where we put it to the academic professors in the UK and across Europe that if they come up with really a fantastic breakthrough, as they regularly do, then part of their duty is to make sure that it gets exploited in the country that paid for the research through the taxpayers' money. And we actually, because he was science minister and in charge of the university, he introduced, very importantly from a cultural change at the university point of view, he introduced a third stream of responsibility for universities. One, of course, is teaching, two is research, but three is translation. So translation became one of the three pillars of university life in the UK after this report. Europe lagged behind the culture change in the UK by a few years, But I'm pleased to say I think most of the centers that you mentioned went through this cultural change. And to say that the Unternehmertum in Munich, for example, is one of the great ecosystems where you have a whole community of people around the university supporting these spin-outs. Of course, we can always do more, but that's not where the problem lies. The problem really lies in scale-ups.
Yeah, absolutely. But this is a really important point you brought up, because I honestly did not know that there was sort of a structural, legal, regulatory piece behind this, of sort of carving out this third leg of the tripod to say translation, or monetization, however you want to phrase it, is just as important as research and teaching, because this is actually the thrust of a study that we've published now 2 years in a row with our friends from Redstone Ventures, who've been looking at the success stories of Europe and how to replicate it. And for them, it really boils down to exactly this. So it's interesting. I thought I knew the UK was ahead. I didn't realize that it was because somebody made a leadership decision and said, this is what we're
It
going
was
to do.
David Sainsbury, yes,
Yeah.
with this report that we all contributed to called The Race to the Top.
That's brilliant. Yeah. I mean, some countries such as Sweden at least let the professors own the IP, which is already a nice step,
Yes.
but still that's not the same as if from the top we would say you have, you have three things you're measured on systematically and as an individual. So that's really helpful. Let's talk about entrepreneurship, because I know you founded IECT and a summer school in Austria. Why do you think it's so important to see entrepreneurship taught?
Well, it is really one of those cultural changes on one hand to encourage young people to engage in spin outs and startups. And I was really surprised by the success of ICT, which ran for 10 years. And I'm very pleased to see, I thought we'd finish after 10 years, but it's now continues under a new name, Hermann Hauser Frontier Lab. And we have another one this year in September. And we've had over 300 companies go through this through these startup schools, and they've raised over €500 million already. So it's been an incredible success.
That's amazing. What is it going to take to get the general cultural attitude towards entrepreneurship to change? Because I think among young people, you sense, especially in the last 10, 20 years, you see so much tech entrepreneurship, dominating the news, and tech entrepreneurs are everywhere. Usually it's the Americans. We all know Elon Musk and Mark Zuckerberg. Most people in Europe, though, can't name some of Europe's leading entrepreneurs. I mean, I think in your lifetime, you've seen, I'd say, a positive shift, I hope, but I don't think we're there. I think we're still a long way away culturally. What for you are some of the sticking points? What do you think needs to change?
It's again the same story about the scale ups. The reason why people like Mark Zuckerberg and Elon Musk are so important in the US is that they have created companies that are some of the largest companies in the US. And one of our big problems is that we only have three companies in Europe, three tech companies that are worth more than 100 billion, let alone a trillion, like in the US. And they are ASML, SAP, and ARM. And we just need many more of that size to be recognized as a technology being not just a startup phenomenon, but actually a very substantial part of the GDP of every country. I think this is changing. So the way I like to describe this, if you look at the ranking of ecosystems in the world, if Silicon Valley is here and the UK is here and Europe is here and Austria is down there, then this gradient used to be very steep. The order is still the same, but the UK is nearer to Silicon Valley. Europe is snapping at UK's lead in Europe. And even Austria now has 3 unicorns. So if you can do it in Austria, you can do it everywhere.
Yeah, I could imagine. I mean, I imagine that the generation that are founding companies now, if it wasn't for the need to go to the US for the capital and that speed, I see many more young Europeans staying here, which I don't think was as much of an option 10 or 20 years ago. So it's mainly, if your investors say you have to come, But in general, it feels like there's a generation now of founders who are quite happy to stay here and proud to be European and want to really drive that.
Absolutely. And of course, I'm one of them. I'm a passionate European. I do feel that we can do this in Europe and be a counterpart to the US and China with cultural differences that we're very proud of.
Mm. Now let's turn to the subject then that flows from that, which is tech sovereignty. It's something that I think you're writing a book on around the
Yes, I
colonialism
do.
of Europe right now, technologically. How do you define tech sovereignty? Because it's something that in a lot of conversations people repeat the phrase, and then you can get into long debates about what that actually means. Because
Yes.
we've been so interdependent technologically, especially across the three poles of Europe, the U.S., and China. How do you define it, and why is it important for Europe?
Well, I'm writing this a book with a colleague called Hazem Nakib, who is a blockchain expert and also a banking expert. He worked for a number of big banks. And when we started off, we thought in terms of three technology sovereignty circles for US, China, and Europe. The argument was going to be if you're not one of the three circles and you had to choose joining one, join Europe. Because it's the only one that's not trying to be a hegemon. It's the only area that has a history of accommodating national differences, Brexit notwithstanding. So this was the original concept of these sovereignty circles. And the sort of assumption that wasn't explicit was that you could be sovereign in the sense of doing everything yourself. And then we wrote the chapter on the semiconductors, for example. And it became clear that there's no way that anybody, not even the US or China, can ever be sovereign in the sense of doing everything themselves unless they want to be incredibly inefficient. So the hyperconnectivity of the semiconductor industry in particular is exemplified by the travel of a chip across 40 country borders before it lands on an iPhone somewhere in China. I mean, the ingots are produced in one place, they're sliced in another place, chips are produced in Taiwan, they're tested in Malaysia, they're then packaged in the Philippines. So they travel backwards and forwards, across 40 country borders before they actually go down. So it's clear that this hyper-connected world is going to stay. So to answer your question, you have to redefine sovereignty as really the lack of a dependence. So because the dangerous bit about not being sovereign is that you become dependent on another state. So you've got to ask the three Hauser questions. First, do we have on critical technologies? Because one of the things that has become clear is that you cannot govern a country and satisfy especially young people if you don't supply the critical technologies that are necessary to run a country and support your economy. And this means all critical technologies. So the three questions are: first, do I have the critical technology myself in this nation? Everything's fine. If not, do I have access to this critical technology from a number of different independent countries so that no single country can use this technological dependence as a coercion mechanism, an economic coercion mechanism to force other people to do things that you don't want to do? If the answer to the second question is also no, the third question is, do I have a guaranteed long-term, more than 5 years, access to a technology from a single country, of course, typically the US or China? And if the answers to all three questions are no, then it's one of those situations where you have to do whatever it takes. Because if you don't, then you expose yourself to this economic coercion from a single country. That is just as bad as occupation by soldiers in the old days. This technology colonialism is a real danger nowadays.
Yeah, that's really compelling. What would you say is our current state of European tech sovereignty? Is it increasing maybe because of the awareness in recent years, or do we still have a long, long way to go?
Well, there are a number of choke points, I would call them, of monopolies or duopolies that exist. Of course, in America, in the chip industry, it's the EDA design software duopoly by Cadence and Synopsys that Trump one used on ARM to do things that we didn't want to do. That's one of the reasons why I'm writing the book. Fortunately, we also have a monopoly position in Europe with ASML. You cannot produce a chip under 5 nanometers unless you use the lithography machine that ASML provides to everybody in the world. All the big companies use ASML machines.
It's a Dutch company, yeah.
It's a Dutch company. And it's amazing that all the world semiconductor companies agreed to create this monopoly because they couldn't finance it themselves. They actually put 8 billion into that company from all the different big semiconductor companies in the world because they trusted ASML to be even-handed. They trusted the political stability of Europe and Holland in particular to do that. And I think it's been a great success. What we don't do, as opposed to Trump, of course, use this as a weapon. And maybe sometime, maybe we should. So if Trump is behaving unreasonably again by weaponizing American technology, we just ought to shoot back and say, okay, you won't get any more of our machines, and there, you won't be able to produce any chips anymore. So, see if you like that.
Why is it so important to have these chip capabilities? You say, especially below 5 nanometers, because I think the German government was celebrating, Intel, which didn't come, but I think they were potentially going to be building bigger chips. Why, in your view, is it so important to be at the cutting edge of where chip technology is?
Well, as it turns out, semiconductors are nature's gift to computing. It is only when semiconductors arrived, we used to have mechanical representation of bits that was unreliable and not scalable, and slow. And then we had valves, which were fast, but also unreliable, and they didn't scale. And it wasn't until semiconductors arrived and that they were fast, they were reliable, and they scaled. I mean, transistors are unbelievably reliable now, to the tune of 10 to the 15. I mean, this is, a million billions of switching events that normal transistors can go through before they show a fault. So it is an amazing development. Now, the reason why I'm mentioning this is because it is actually the semiconductors that is the basis of pretty much every critical technology that we now feel is so important in our lives. Smartphones, computers, telecom networks, 4G, 5G, 6G. So pretty much anything that has to do with technology. And now, of course, AI, this wonderful revolution that we're living through of generative AI and now agentic AI, where we will enjoy the company of a new species, which will be intelligent agents. And of course, none of this it would be possible if it couldn't run on semiconductor chips right at the bottom of it. So that's why semiconductor chips are just essential for any sovereign nation.
No, that makes total sense. What do you, we've often had conversations about quantum, and I know you're an active investor in that. Why are you so excited about where quantum computing and quantum technology is taking us? It's still very early, and there's still different, religions, if you will, or threads of the development of where the technology could go or how it could be used based on whether you, believe in neutral atoms or superconducting. I mean, there's sort of a lot of schools and we're in the exploration phase, I guess you'd say right now. What is it that excites you so much about quantum computing and communication?
Yes, I've made 7 investments in that field already, and it is well past the exploratory stage. We have a number of working quantum computers. They're very small still. They've got a small number of qubits, as they're called, and the excitement really has to do with qubits. So bits, as you know, have 2 states, so 0 and 1. A qubit is a strange animal that lives sort of between 0 and 1. a qubit will have a certain probability of being zero when you measure it, or one. It can be 10% zero and 90% one, or 50% zero, 50% one, or 70% zero, 30% one. And it is that gradation of the mix between zero and one called superposition, together with entanglement, that gives the quantum computer its unbelievable power. So just to give you a feeling for how powerful these quantum computers can be. So the performance of a classical computer rises linearly with the number of bits that you have in a computer, but it rises exponentially with the number of qubits in a quantum computer. So every time you add a qubit to a quantum computer, it doubles the performance of a quantum computer. So a quantum computer will be able to do things that classical computers will never be able to do, because it would take longer than the age of the universe to get an answer. So the contrast couldn't be starker. It really is a spectacular difference in potential performance that we'll start enjoying 5 to 10 years from now. There are different projections.
Yeah, which do you believe more, 5 or 10 years?
Well, I'm the perennial optimist. I think it's going to be closer to 5 years than 10 years.
What use case excites you the most about it?
Well, there are three main use cases for quantum computers. There is this excitement about the RSA cracker. So the most famous algorithm in quantum computer is computing is called the Shor's algorithm. And Shor's algorithm is known to be able to crack RSA 2048, which is the main encryption standard that is used by all our banks, by the WhatsApp, encryption standard that people use when they talk to each other. So that's why $55 billion of government money is available worldwide in quantum computers, because every country feels they have to have one, because it's just not on that other nations will be able to read the secret messages that you used to send out, and everybody is storing these secret messages in the hope that the quantum computers will be able to decrypt it in the future. So there's a lot of government money going into this. It's the first time that I've seen a new technology where a market exists, the government market, before the real market exists, because they will have to invest in it for every nation to have a quantum computer. So cryptology is one application. Optimization problems, is another one, logistics, etc. But you asked for the most exciting application in my mind, and that is simulating quantum systems. Why that is important is the simulation of quantum systems, i.e. molecules, will allow us to simulate the way a drug molecule binds into a protein and is effective for our health. So long term, we might have the vision of doing drug trials in silico, which would speed up drug discovery enormously and find drugs for every one of our diseases. So that's what I think is going to be the most exciting application of quantum computers long term.
That's brilliant. What are some, besides quantum, what are some of the other areas that you think, so put on your European hat here, thinking strategically, what are some of the other areas where if you were President von der Leyen or if you were King of Europe, you could decree that we would be really putting a lot of focus on? Because we can't place, there's limited capital, even at the state level or the private investment level. What are for you the key areas where the continent of Europe should be placing its bets next to quantum?
Well, it's really three: quantum, AI, and synthetic biology. AI is the obvious one, and there are lots of AI initiatives, of course. And one of the things that I must say is out of whack in Europe is the amount of time that we spend on the ethics and the societal implications of AI, which is, of course, an important thing that we ought to talk about, versus rolling out AI and getting the productivity increases that we can get from AI. If you ask me, the balance should probably be 1 to 100. There are 100 times more should be done on rolling it out. And I always like it to electricity. There were these famous events put up in New York about electricity killing an elephant. Now, of course, electricity is very dangerous and it can kill an elephant, but that turned out not to be the key issue with electricity. The key issue of electricity was nations rolling out fast to get the benefits of electrification of their factories, which increased the productivity and the ability to improve the quality of life for their people. And so it is with AI. It's the speed of the rollout of AI across Europe, which fortunately we can do because there are a number of the foundation models are open source from Meta, but also from DeepSeek, also from Mistral. We do have our own. So that's really what we need to do: roll it out across the all the sectors. Because one of the unusual properties that AI has is that it is generic for all sectors, and will get productivity increases across our entire economy. But again, the most important of the three long term, I think, will be synthetic biology, because it is synthetic biology, understanding how biology, and we are biological animals, how that works, because it concerns our own health, our longevity, our being as biological entities. So that's why I think synthetic biology will be the most important of the three.
That's fascinating. And I mean, luckily, it's biology in general, pharma and biology is an area where Europe has innate strengths and some, incredible companies. I guess there's a danger there that upstarts could come along with quantum computing and AI and supplant these companies in Europe. So it is in that regard a warning as well that we have to protect some of the hard won industrial areas that we have through that tech. That's really illuminating. Thank you. One thing that I would also ask you about related to this is, there is a war on the eastern front of Europe, and a lot of the technology world has been changing its thinking in recent years about the use of technology to defend democracy. In many ways, whether it's on the battlefield or on the internet. How do you think Europe's defense needs are going to be playing into these tech debates? There's a lot of talk about how to build better bridges between the defense primes and the startups. And there's a lot of innovation happening in Ukraine, as you know. They're really starting to really lead the way in redefining what it means to fight an AI or a drone-enabled war. What do you see as the defense aspect to all of these tech topics?
The Ukraine has really changed in the same way that we had that culture change of professors not wanting to get involved in spinouts. The venture capital community never wanted to get involved in defense. With Ukraine, this has changed dramatically. I think most VC companies are now quite happy to invest in dual use. And especially in drones and AI for drones, because drones really seem to have changed the strategies in the battlefield dramatically. Also communications, just the entire way in which battles will be fought in the future, hopefully without people in it, is changing at a speed that is just unbelievable. And as you said, the Ukraine is really leading the way there. So we've got to learn from that. As you know, all European countries that used to be pushed to increase their spending, their defense spending to 2%, all talk about 5% now. I mean, there's been a complete shift in the way we've got to be responsible for our own defense in Europe, because we can't rely on the US anymore. And the technology community just has to make its contribution if we don't want to be overrun by Russia.
No, good point. We're almost at the end of our time, so I'd love to jump into what we kind of call the lightning round, which is just a few quick questions to take us out and get some quick thoughts from you. If you had to start over, I'm thinking back to that conversation where the local physics professor had to have a talk with your father. If that maybe had gone differently, if you had to start over and be outside of technology in the career you're doing, what sector would you pursue your career in?
On the outside of technology?
Yeah. Would it have been in physics or something completely different?
I think I would do physics. Yes. Actually, no, probably biology.
Biology.
Yes.
A close cousin of it, but interesting. Yeah.
Yes. You know, biology finally has become a science. There's a famous quote by Rutherford about sciences, and he says there is physics and then there is stamp collecting. uh, Biology was always stamp collecting for me, because the way I learned biology was counting the number of petals on a flower to determine what flower type it was. And then, I went back to our lectures on molecular cell biology and realized this is very much a science now. We really understand the details of biology, and it's very exciting. And I actually make more investments in life sciences than in ICT now.
That is interesting. Yeah, it is funny. You go to the Natural History Museum in Berlin, and you feel like you're mainly looking at stamp collecting of everything that von Humboldt was gathering when he was in South America. So for decades or for centuries, it really was stamp collecting. I can see that, but it's a whole new world now. What's something you love about Europe?
Well, the diversity and the history. I just love traveling around Italy, the UK, of course, my native Austria, France, Germany. They're just all lovely and very diverse countries. And the thing that makes me so proud as a European is that we're the only area in the world that has managed to create a governance layer above the nation state that sort of works. We bitch about Brussels all the time, but the euro is the second largest, second most important currency in the world. We've got the largest free trade zone in the world, so there are lots of things to celebrate.
That's brilliant. Tough question here: Cambridge or Tyrol or New Zealand?
Well, the answer in my life has been all three. I'm in Vienna at the moment. I love Cambridge, but my wife is a Kiwi, and we have a wonderful farm with our own beach down there. So we do like to spend the winters then.
That's great. Yeah, you don't have to make the choice. You've had a long career in technology. What's the best piece of advice you think you've ever received?
Well, there were really fundamental decisions that I had to make about my life. One was whether to study physics or go into my father's wine business, and I told you the story. Another one was a piece of advice I got from the person who ran Logica when I got this offer from Olivetti to become vice president of research, which was just a wonderful 3 years in my life in Ivrea. I moved to Ivrea for 3 years. And his advice was, well, Herman, what do you want to really do? And I said, maybe in the long term, I want to be in technology and maybe start another company. He said, then take the job, find out how a big company works, at the highest level, at the VP level. You've got this fantastic opportunity of doing that with Olivetti, which was the number one PC company at the time. And a wonderful organization to work with Carlo De Medici, one of the great entrepreneurs in Europe that I worked with closely. So that's probably was the best piece of advice I ever got.
That's brilliant. Yeah, do the learning curve. Two questions left. One, a fun one. What's a piece of tech that you really miss from the early days, 80s or 90s, or even 70s?
Tech that I miss. Well, I always rather liked slide rules. uh, and I don't know where my slide rule is, but I always, if the electricity goes out and the batteries run down, the slide rule will still give you the right answer to your calculations.
That's brilliant. Final question, Herman, and really a joy spending time with you. Let's end on a positive note. Tell me something that makes you optimistic about the future of Europe.
It's diversity. I think at the end of the day, if you let people in a free society, which fortunately we still are, we are not occupied by Russia yet, we can let 1,000 flowers bloom, and we are. And I do enjoy this enormously.
That's terrific. Well, thank you so much for your time and everything you're doing for Europe. Thanks so much for being with us.
Well, thank you for the chance to talk to you.